Let's talk about this idea of introducing a new score or removing a score. Adding a score to a distribution or removing one will often change the mean. Most cases it will. The exception is when the new score is precisely equal to the mean. It's easy to visualize the effect of adding or removing a score if you remember this idea of a balance point. So if you take a look at this previous illustration we had, what if we put another 9 on this seesaw, or added a 9, or added a 10? In that case, that would certainly make the seesaw drift off to the right. It would pull it down on the right. Conversely, what if we added a 3 or a 4? That would make it tip the other direction. So that would lower the mean. Adding a high number raises the mean. Adding a low number lowers the mean. Fair enough. Removing a score. What if I removed the 10? Wouldn't that make the mean be lower? Of course it would. It would tip to the left. What if I removed the 1 and the 2, or just the 1 or the 2? In that case, it would make the seesaw tip to the right. So it's a helpful analogy there. In rare cases, and let's cover the possible impact of removing or adding a score on the mean. We've got the original 3 numbers that are part of a population. What if I added a 5? 5 is higher than all the rest of the numbers, and of course that would increase the mean, that middle scenario there. What if I removed a 1? Instead of 3, 2, 1, I've just got 3 and 2. Well, that raises the mean. I removed a low number, which raises the mean. Wouldn't you like to drop your lowest test score in a class? Wouldn't that have the effect of raising your mean? Of course it would. Conversely, as I look at the middle, wouldn't I like to add a test score that was really high? That would also raise the mean, of course. Another possible situation is it has no impact. And here's where it says possible lack of impact of removing or adding a score on the mean. Let's take the original 3 numbers, and I love to be simple. These can always be illustrated with terribly simple numbers. What if, and you can see the mean is 2. 3 plus 2 plus 1 divided by 3 is 2. What if I added a 2? Well, as you can see, it doesn't change the mean, because the number that we add is precisely the same as the mean. Conversely, what if I took those 3 numbers and removed a 2? What happens then? Well, in that case, the mean remains at 2, because when I add or remove a number that happens to be precisely the same as the mean will not change. And of course, you can experiment on that with any array of numbers. So it's a fairly direct concept, but it's, I think, quite interesting. So in this case, I would say that when we add or remove a number, the great majority of times, it is going to have an effect on the mean. If I were to add a number that's higher than the mean, in that case, it'll raise the mean. If I add a number that's lower than the mean, of course, that's going to lower the mean. If I remove a number that's higher than the mean, that'll have the effect of lowering the mean. If I remove that 10, of course, the mean's going to be lower. If I were to remove the 1, let's say we remove the lowest quiz score, in that case, it makes the mean higher. It's going to tip over to the right side. So this seesaw example is actually pretty beneficial. In rare cases, if we happen to remove or add a score that's precisely the same as the mean, in this case 2, it doesn't change it. So it's kind of a qualifier. So if I were to ask a question, adding or removing a score definitely changes the mean, and the answer would be false, because I might be adding or removing a number that's precisely the same as the mean.